Now, as you might have seen in the previous video, we can measure angles in degrees or in radians, okay? So what happens is one complete rotation of a ray about its endpoint. So again, for effect, I'm going to draw this over. Here's my initial side, right, the positive x-axis. One complete rotation of a ray about its endpoint, right, it's about its vertex, about the vertex of the angle. If I completely rotate it around in a circle, what have I formed? I formed a 360-degree angle. Or if you want to think about it in terms of radians, it would be 2 pi radians, right? So 360 degrees or 2 pi radians if you go completely around the circle, right? If you rotate it completely about its endpoint one time. Okay? Now, any angle that's between 0 and 90 degrees, so if I have an angle like this, that would be an acute angle, right? It's less than 90 degrees. Of course, if you have a right angle, that's a 90-degree angle, right? So this here, that would actually be a right angle because it's 90 degrees, all right? And now, use a different color, I guess. An obtuse angle is going to be an angle between 90 and 180. So an obtuse angle would be something like this. And then a straight angle, I'll use green again, would be 180 degrees. And it makes sense that it's called straight because what does it form? It forms a line, right? It forms a straight line, right? It's basically just having the ray go in opposite directions. So you end up forming a straight line. So that would be a straight angle, which is 180 degrees. All right? So you have acute, you have right, you have obtuse, and you have straight. Now tying in with the different types of angles, acute, right, obtuse, and straight, we can also talk about different quadrants, right? First, second, third, and fourth quadrant corresponding to specific angle measures. Okay? So any angle, and I'm going to stop using different colors now. Right? We know that these are all in standard position, so the positive x-axis is the initial side. Right? So each quadrant corresponds to a specific angle measure. So any angle that's in the first quadrant, any angle whose terminal side is in the first quadrant, right, would be between 0 degrees, right, if it hasn't rotated at all, and 90 degrees, right, because 90 degrees would make a right angle. So any angle in the first quadrant is going to be between 0 and 90 degrees, right, not including 0 degrees and 90 degrees, right, because those are right on the axes. Okay, so any angle between 0 and 90 degrees is going to be in the first quadrant. Now, if you're in the second quadrant, you've gone past 90, but you haven't gone as far as a straight angle, which would be 180. So any angle in the second quadrant here is going to be between 90 degrees and 180 degrees. And then you can probably see where this is going now, right? In the third quadrant, you've gone past 90, past the straight angle, and into the third quadrant. So all the angles here are going to be between 180 and 270. And then in the fourth quadrant, you've gone past 90, past 180, past 270, and into this fourth quadrant. So the angles in here are going to be between 270, and 360. All right, and of course, if you're dealing in radians, right, 0 to 90 degrees would correspond to 0 to pi over 2 radians. 90 to 180 would correspond to pi over 2 to pi radians. The third quadrant would correspond to pi to 3 pi over 2 radians, and then the fourth quadrant would be from 3 pi over 2 to 2 pi radians. Right? Because again, 2 pi radians is once around the circle, which is 360 degrees.